Or not.
Hello and welcome back to Elementary Algebra section 5.2 on addition and subtraction of polynomials. Before we do the problems which are spelled out in the title, we have to first learn the words, terminology that is necessary for the rest of the chapter 5 and 6, and then later courses in math as well. So we are going to start first with the word term. And term is described as a unity of constants and variables, right? So constants and or variables held together by multiplication or division. It's a mathematical construct, and we learn what it is, and we go from there. So, examples of terms: 3x squared, number 10, or negative 4xy squared, or x over 6. All of these are examples of terms. They can only be that you can only have, let's say, ABC squared, whatever. So you can literally put whatever you want as long as it's all of its components are only held by multiplication and division, connected by, right? So if you take a look at the first term over here that I wrote, it's 3 times x squared. You have over here negative 4 times x times y squared. So those are all the multiplications, and here is x divided by 6. That's a division symbol. So the terms are always entirely made out of constants, which are the numbers, and then the variable part, and those are, or multiple variable parts, and then, well, no, it's a variable part that can contain multiple variables. And those are all glued together, put together using multiplication or division. So now what we can do is we can put a couple of these terms together and create what we call polynomials. So terms are separated by addition and subtraction. Terms are separated by addition or subtraction. So now, when I write x squared plus 3x minus 6, I know that there are 3 terms in there, because we have 2 of these signs which are used to separate terms. So we have term number 1, term number 2, term number 3. So 3 terms because they are separated by addition and subtraction. You can have 2x plus 9. That would obviously be 2 terms because you have only one positive, right, one addition, and that one addition there separates the term 2x and separates from the 9, which is also a term, because remember, term can be combination of numbers and variables, but could also be just a number or just a variable. So 9 is a term. We would actually give it a name later and call it constant term because there is no variable in it, so it cannot change. Where the variable terms obviously depend on the value of the variable. That's why they are variable. They could be, they can vary, right? They can get different values. So it's very simple to count terms as long as you learn what these definitions mean. So term consists of constants and or variables. So you can see this term at the end does not have a number in front. Well, it does, it's number 1, but you know, it doesn't have -4, it doesn't have 1/6, it doesn't have 10 or 3. So it is just the variable part, we would say, where this one is just the constant term, is just a number. So those are terms, and then the terms are held together by multiplication and division, and they are separated by addition and subtraction. So anytime when you see addition and subtraction, that means that the new term begins right after that sign. So now we want to learn more words. When you have one term, we call it monomial. That's monomial. Word mono means one. And then we have two terms. Those guys will be called binomial. Word bi in Latin, two. Then three terms. Special name is trinomial. Word three. I don't have to explain that one. It's just spelled differently. And then four or more is simply called polynomial, meaning poly, meaning many, from Latin as well. So these are the ones that you will probably have questions on exams and the homework, where you have to state whether the given expression is a monomial, binomial, trinomial, polynomial, but it literally is just counting. So if I just go one term, I can say, let's say 2xy as an example, and then two terms, x plus 3, that's two terms. Three terms, famous x squared minus, let's say, 3x plus 4.
So is that three terms or four because of the x squared?
This is 3. 1, 2, 3.
I wasn't sure whether you'd be counting the x multiplied by itself.
Well, that's one term because x times x, there's still multiplication in between, so it's a one term. Whether I write it x times x or x squared, it's still going to be the same one term. And then polynomial for more than 4, so 3x to the 7 plus 5x to the 4 minus 3x squared plus x minus 1, let's say, right? That's many terms. So any value of any number of terms, 4 or more, will immediately be called polynomial, for word for many. So poly means many. And these are the words that we need to know. So we have term, then and what it means, then how to know when the term ends and the new one begins, and then monomial, binomial, trinomial, polynomial, meaning these are the terms that we, but just by number of terms it has, we will go. So you will frequently hear square of binomial, right, and so on. There will be a formula coming up very soon that will be called square of binomial. If you don't know what binomial is, then clearly formula that it's named square of binomial is not going to go well. So you need to, right, study in order and actually study to learn, so that later on when it shows up, you know what it means without making an excuse, oh, that was a month ago. Right? It doesn't matter whether it's a month ago or a year ago, right? Mathematics always builds up, so we need to know these terms. And now the only thing that it's left for us to do is to work on addition and subtraction. And I'm just going to tell you that you add and subtract polynomials by adding or subtracting like terms. So we just have to define what the like term is, and the rest should be just practice of problems. So now we are going into addition and subtraction of polynomials. So here in blood, to add or subtract polynomials, we need to add/subtract like terms. Now, what is the like term? Like terms. So, two terms are called like terms if they have identical variable part. So, examples for like terms. We have 3x squared and negative 9x squared. Those are like terms because one of these terms has x squared, the other one has x squared. Those are the variable parts, and they are the same. That's why these two terms are like. So now, because they are like, you can add them, right, and get negative 6, or subtract them and get positive 12x squared. We'll deal with that later. Now we're just focusing on like terms. So in order to add, you have to have like terms, and the like term only cares about the variable part of your problem being exactly the same. So let's take a look at another example. So say you have 2xy and 10yx. This one tripped a lot of people, and they said no, it's not like. They are like, because x times y is the same thing as y times x. It's just a commutative rule.
Oh.
So these two terms are like because of the commutative property. If you remember, commutative property was a times b is the same as b times a. Well, if you learned it with a and a b, you can still apply it to x and a y. There is no difference, right? It's just the different letters, but it's the same mathematical concept. So, yes, these are like terms. Yes, these are like terms. And now I'm going to have 4x squared y and 6xy squared. Are these like or not like?
I'm going to say yes.
You're going to say yes.
They're not because of the exponents?
Exactly. They are not because exponents are not the same. You see that the first one has two x's and a y, and the second one has x and two y's. So they are not the same because, right, two x's and only one x. And that's enough for us, not even looking into y's, because identical variable part means they have to be absolutely the same. In our case, we don't have that, so this is going to be the one that it's not like terms. So sometimes you have to kind of check a little bit, be careful, right, not to miss like terms, but in general, right, you should be able to spot the situation when they're not like terms because the variable part is not identical. All right, so now let's just add and subtract these guys. So you are going to add and subtract like terms. So if I have 3x squared plus 6x plus 13, and I want to add to that x squared minus 1. Remember what it said, add/subtract like terms. So these two terms are like because they both have identical variable part. So we are free to add these two terms. So that will be 3x squared plus 1x squared is 4x squared. You can also literally say 3 apples plus 1 apple is 4 apples, right? So we're going to have over here 3x squared plus x squared. Then, why did I write this? We have 4. We already discussed this, right? You have these two that are the same. Now, this one is solo. There is no other term, right? You have 5 terms, 1, 2, 3, 4, 5. It has nothing to combine with. All other terms have different values for variable other than x. So that one we just have to copy, right? It's just 6x right there. And then finally, let's go, I guess, green for these two. Because this one and -1 also combine because they are like terms.
Yeah.
Because they're both numbers. So 13 minus 1 is
12.
And that's it. So we were able to add two polynomials, and the way we did it is like terms. So x squared goes with x squared, produces x squared. That's it. Single x did not have anything to add with, so we just copied it as is. And finally, number 13 minus 1 is 12. And that's when you have addition in between. All right, so here is the problem for you to enjoy. So 4x squared y plus 3x plus 4y minus 6 plus y minus 2x minus 2 or minus 6, let's say, x squared y. So please remember your goal is to find like terms. Look for like terms. Those are like. You can invent your own code on how to separate them so you can find them. So visually, right, find them all and then go ahead and add the values. Because you can literally say 4 apples minus 6 apples, right? You don't have to use x squared y. How much is 4 minus 6?
-2.
-2, very good, x squared y. So that's our first term. And then we have 3x minus 2x. That's plus x, right? Because 3 apples minus 2 apples is 1 apple. Plus 4y plus y is plus 5y. And then this 6 at the end has nothing to go with. So sad and disappointing, right? So let's take a look at another one. Something similar that they would give you in a book. So 25a squared b plus 6ab plus b, and then add to that 13a squared b plus 4b squared minus 10ab. So you can do your own code to underline like terms and then add them all together. I'm just gonna go grab a bottle of water. I'll be right back.
Okay.
All right. I hope you had enough time to think about it. These guys are like.
Yeah.
And these guys are like.
Right.
And the rest is unlike. So we have to just put those at the end. So 25 plus 13 is 38a squared b. And then 6 minus 10 is negative 4ab. And then we have plus b and plus 4b squared. Come on, tablet.
And that's the answer.
I hope you're not disappointed because that's it.
That's a long answer.
Well, such is life. Now, the next problem is 3x squared plus 6x minus 3 minus x squared plus 9. When you have a subtraction in between, please make sure you distribute that negative to every member of the parenthesis. So try working this out on your own. As it's the same as subtraction as addition, except you have to distribute the negative. You still look for the like terms and all of the same business as before. All right, let's take a look at this together. 3x squared plus 6x minus 3. And here is minus x squared and then minus 9. So I have to take this negative and distribute to the second parenthesis. Now I go and I say these are like and these are like.
Right.
So 3 apples minus 1 apple, that's going to be 2x squared. This 6x has nothing to go with, so we'll just copy that. And then minus 3 minus 9 is negative 12, right? Because we make it worse. It was already bad, negative 3. And then you make it worse by subtracting another 9, gets you negative 12. So we use the same technique of like terms. The only new step was distributing the negative to each member of the parenthesis. Three x plus 6 minus 4 plus 6x minus 9x squared, let's say. So try that one, same steps as always. Okay, so what should I write to distribute a sign? 3x plus 6 and then what?
Negative 4
Okay,
minus 6x
okay,
plus 9x to the second.
excellent. Perfect. As my MATLAB would say, fantastic. Yes. All right, so now like terms.
3x and 6x.
9x squared has nothing.
Right.
3x and 6x, good. And then we
Or
have
6 and 4.
yes. Now, one piece of information, when you start writing your answer, you go in the order of the descending powers, descending exponents. So 9x squared is the first because it has the largest exponent. And then we go 3x minus 6x is minus 3x. And then at the end plus 2. So always in the order of the descending power. So this is this one, this is this one, and this is the one with the arrow. It is very systematic as long as you remember to distribute the sign so you don't miss something right there. Let's go and take another example, and we're pretty much done. I mean, there's not much to this stuff. You just have to be careful what's like, what's not like, that's all. So 2ab squared minus 4b squared plus a plus 9 minus 10 plus 6b minus 6b squared plus ab squared. So I'll let you think about this and try and solve it on your own. Let's get rid of the parentheses. So for the first one, you can just remove them. But for the second one, you have to do some work. So what should I write for the second 4 terms?
Can I go for it?
Well, I guess no one else wants to, so why
Okay,
not?
so negative 10
Okay.
minus 6b
Yes.
plus 6b to the second
Yes.
minus ab to the second.
Yes. And now we do the pairs. There's that one, the b squared pair, and this one. And then we have a and b solo that do not belong anywhere. So how much is 2ab squared minus ab squared?
1ab.
Yes. So we can just write ab squared. So that's the squiggle. Then let's go to the b squares. We have negative 4b squared plus 6b squared. So that's technically 6 minus 4.
2.
Yes. 2b squared. We have plus a minus 6b. And finally, 9 minus 10 is?
8. Oh, 9 minus 10 is negative 1.
Negative. That's it. Yeah, that's all we need. So we learned that the term is the term consists of variable part and the constant part, the number part, and they're put together using multiplication or division. And then the terms are separated by addition and division. So addition and subtraction. All right, so terms are collections of variables and numbers, and terms are held together by multiplication or division. Now, to distinguish between different terms, we have in between them, we have addition and subtraction. So that's how we know that the new term started, because the term does not contain more than one of these groups of numbers or variables or whatever. In order to add and subtract, we need to find what we call, right, the like terms, and then the like term is something that is described as where the two terms have identical variable part. And the word identical means a lot, because ab squared with ab squared is a like term, right? But if you have ab squared and just b squared, they're not. So these are the like terms, and these are the not like terms. Yeah, I understand that they both have b squared, but the first term also has a and the second one doesn't, which means they're not identical. They have some differences between them, therefore they're not like terms, and we can't add those. And that would be it. That's the little quick summary of what we just learned. The homework will open. Now we're going to take a 5-minute break, and when we come back, we are going to go and talk about the review for the class, for the exam this weekend. So I will see you in about 5 minutes. Here comes the epic music.